circles are polynomials. And the ones that aren't are not polynomials. Okay, well, let's look at the ones that are not polynomials. Down here, why do you think that guy's not a polynomial? Yeah, Ellie? It's got a negative exponent, so they can't have negative exponents. Okay? No. So what can't have a negative exponent? The variable. The coefficient can, but the variable cannot. So this one, does the variable have a negative exponent? No. So the key is the variable. What about, that's why this one's not an exponent. What about this guy here or this guy here?
Looks like they both have radical.
Just the variable is, keyword is variable, is in a radical. So that's why this one's not and this one's not. How come that one's okay? Yeah, just the 4 is in a square root, the coefficient, but the variable is not part of a square root. So it can't be in a square root. It can't have a negative exponent. Why do you think these ones here, I shouldn't use purple because then it looks the same. Why do you think this one here and this one here are not polynomials? Yeah, you're on the right track. They're fractions, or specifically the variable is on the denominator. So your variable cannot be on the denominator. Your coefficient can, but your variable has to be on the numerator. Okay? It's just not, though, that by definition, that's not a polynomial. Polynomial always has, sorry, I should say whole number. Yeah, whole number exponents. This one? Okay, the x is not under the square root, just the 3 is. Okay? All right, so moving on. A polynomial can have constant variables and exponents. So the exponents have to be whole numbers. Okay, the exponents of the variable, has to be whole numbers. Okay, so here's some polynomials. Those are not. So what are terms? When I say how many terms does this have? Yes, Carson. How many terms does 2x squared plus 6x have? 2. So what are the terms separated by? Yeah, they're separated by plus or minus. We'll tell you how many terms something has. So a monomial, how many terms is a monomial? One term. Mono means one. So that would be an example. Give me an example of monomial. 6x or 6y. Yeah. Okay, binomials would be 2 terms. An example of that one? 6x plus 7y. Sure. 7y. Okay, and a trinomial has 3 terms. So how about 2x squared plus 5x plus 1? That's kind of like the trinomials we're going to see a lot of this unit. Okay, so on the next page is a legend. You've seen this before? Yes. No?
Yes, but I don't remember quite.
Okay, well, it's part of this curriculum, so you do have to know them. So we're going to use the positive as the colored side, or the filled in side will be positive x squared. I should probably, again, use a different color. Okay, and the white side will be our negative. Okay, so what piece would this be? X, which makes sense, because if this is an x squared, it's because its dimensions are x by x, which make an x squared. So this is an x, and its dimensions are x by 1. So an x, oh, again, the red's in the wrong spot. Let's do that. Okay, in there? Okay, we're having issues. Okay, something's wrong. And this would be our negative x. Joel, can you move to the front of the row, please? Thank you. And what would this guy be? 1, and this would be negative 1. Okay? Yeah, thank you. You're so sweet. Okay, so next page. What would this represent? Plus 1. Yeah, negative x squared. We have 3. Carson, you're going to move next. 3 x's plus 1. Okay, what's the next one? 3x squared. Good. What happens if you have a plus x and a minus x? It cancels each other out. The red marker does not like me today. Okay, so we won't even write it. And then, what about here? What would be our net? Plus 1. One of the minus and positives would cancel each other out. They would zero each other. So we'd have left with plus 1. 3x squared plus 1. Okay? All right. To add polynomials, we collect what? Like terms. You remember? Okay, a little note here about these brackets. Okay? Are they actually necessary? Okay, they are not. So in this case, the brackets here are not necessary.
Mr. F, please come to the office. Mr.
2
F.
C's? Is it 1 C? It's 1 C, isn't it? Okay. So why are these not necessary?
They're all the same.
No, let's look at them inside. In front of this, is there anything in front? There's nothing in front, or it's just a plus sign. So if it's by itself, there's nothing in front, or it's a plus sign, then it's not necessary. Okay, so we can just go straight to collecting like terms. They were just grouping them, but it wasn't necessarily necessary. Exactly. So where are our like terms? Give me one of them. 3m squared. We always go highest to lowest. So we always go highest degree to lowest degree. So the m squareds are like terms. So if we have 3m squared plus 4m squared, how many m squares do we have? 7m squared. When we are adding, it's not like multiplication, right? Adding, we keep the same base and just add the coefficients. All right, then next we have 2m plus m is 3m. And then last, 7 plus 9, 16. Okay, please solve the next one on your own. Give it a shot. So we have to have the same variables and those corresponding variables have the same exponents. Okay, are you done? Yes, no? Okay, the a squareds b are like terms. They have the same variables with same corresponding exponents. So 3a squared b plus 2a squared b, 5a squared b. minus 2ab plus 4ab
2ab
plus 2ab, and then a 4b squared minus 2b squared
plus 2b squared.
plus 2b squared. Okay? So like terms have to have the same variables and the same corresponding exponents. So a squared b and ab squared are not like terms. You know, in this one it wouldn't matter because they're both degree 2. We figure out the degree of it by the sum of the powers on the variables. So here this is a power of 1 and a power of 1, so its sum is 2. So they're both degree 2, so it doesn't matter the order of those two. Be either or. Okay, to subtract polynomials. So we're going to use, I find the easiest way to solve with subtraction is to distribute the negative. And then add. Because addition is easy. Right? Students don't make mistakes with addition. Often mistakes are made with subtraction. I've even seen that on your test yesterday when you're trying to subtract negatives, right? In your the exponent laws. And so if we can avoid just using subtraction, if we can make it addition, it's going to be a lot easier. So how do we do that? Well, this negative, who is it applying to? The first bracket or the second? The second, right? It's in front of the second. So the first one stays the same. Is that first bracket necessary? No, but we can leave it if it's just grouping them. It's not really doing anything. So we want to change this to addition. So what, by distributing the negative, what happens to all the signs inside? They're opposite. We're multiplying it by negative or negative 1. So the positive 2m squared becomes negative 2m squared. A negative 1m becomes positive 1m. And a positive 3 becomes negative 3. So now we have addition, so let's add. So, like terms again, 4m squared plus negative 2m squared, 2m squared. 3m plus 1m is 4m. And 2 minus 3, 2 plus negative 3 is negative 1. Okay. So here, there should be a subtraction sign. We're going to subtract those two polynomials. I'm subtracting the second from the first. So how do I make this addition? Whose signs are we going to change? The top or the bottom? The bottom one. So we're going to make this addition. So this guy is going to become positive. The 4 is now going to be negative. And the positive becomes, or negative becomes, thank you, positive. So now let's go ahead and add. Negative 4 plus 3. Negative m squared. Now we have negative 5 plus negative 4. Negative 9m. And 3 plus 8. 11. So we're going to switch those signs and then add. Do you want to try the next one on your own? Or do you want to do it together? Okay, give it a shot. That's okay. So we distribute the negative to the bracket that it's in front of. We can change it to addition. And now we can collect like terms because these brackets aren't necessary anymore because we just have plus signs or nothing in front. So the x squared is 2x squared minus 3x squared plus 6. Well, 2 minus 3? Nadia. 2 minus 3? Negative 1 plus 6? 5x squared. Okay. Negative 3 plus 2. Let's go another color here. Negative 3 plus 2. Negative 1x minus another 5. Negative 6x. And then last, we still have the plus 6. He's by himself. There you go. Good job. Okay, the next page, I don't know if we need to cover. We just finished a whole unit on this. Multiplying monomials. We just did this, right? So we talked about S&L, sign, number, letter. Sign, the coefficients. When I say number, I mean the coefficients. And then the letters are the variables. So when multiplying here, we multiply the coefficients. So 3 times 7, 21. Now, when we multiply same bases, what do we do with our exponents? We just finished them. We add them. So what is the exponent if you don't see it? 1. It's good to write it in if you forget it, that it's a 1. So for x, it's going to become x to the power of 3, y to the power of 2. What's 2/3 times 9? 2/3 of 9. 6. And x times x? X squared. Okay, dividing we just covered as well. I'm not going to write a whole bunch of notes because we just finished this unit, but it's the same thing. We divide our numbers, and when we divide our same variables, what do we do with our exponents? Subtract. So 34 divided by 17, 2. Okay, 2. X to the 4 divided by x to the 1. X cubed. And what happens with y divided by y? Cancels, because we get y to the 0, which is just 1, so it's gone. Okay, how many times does 9 go into negative 36? Negative 4, and then m. M cubed divided by m squared is m. Yeah. So we just finished that. That's review. Should not be a problem, especially that level compared to what you were just dealing with, right? That's easy. All right, distributive property. Everyone's favorite thing. Multiply the term on the outside. Yes. Okay, so we're going to multiply the term on the outside with the term on the inside. I forgot the word sorry guys. Multiply the monomial by each term in, let's say, in the brackets. Parentheses. Yeah. Multiply the monomial by each term in the brackets, or in the binomial, or it could be a trinomial. Should we do the example? Should we do one of the examples? They're pretty easy, yeah. Okay, pick one. Last one? Sure. Is it a fraction there? Okay, so 8 times 3 over 2. So here's a hint if you want to do this really quickly. You go 8 times 3 and then divide by 2. Or 8 divided by 2 times 3. So 8 times 3, 24 divided by 2, 12. And then we have x times x. X squared. Right, we add the exponents. 8x times negative 2. Negative 16 and x. Very good. Okay, it might have been a while. I don't know if you remember dividing by a monomial. Kind of. Has anyone ever seen this before? Okay. That's good. I don't really like it. Okay, so when we divide a binomial, trinomial, polynomial by a monomial, really, we're just going to divide each term on the numerator by the monomial. It's pretty easy. We're dividing each of those by 2x. So what's 6x cubed divided by 2x? 6 divided by 2 is 3x to the power of 3 minus 1 gives you 2. And what's anything divided by itself? Reduce. Okay, but what does it actually equal though? 1. So we should actually say reduces to 1 is the proper way to say that. When we say cancel out, it actually assumes 0 property, but it doesn't actually have a 0 property. It's just reducing to 1 over 1. Do you want to try the next one on your own? Okay, we're almost done. It's short. Not today. Yes. Oh, yes. I moved. We're live. So divide each by 2a. You should have 10a squared minus what? 2. A is reduced to 1. A is reduced to 1. Okay, what is the width of the rectangle? So they give us the length and they give us the area. So what formula do we know for rectangles? We're dealing with area. Area equals L times W. So if we're looking for width, what's the new formula? What would width equal? How would you get width by itself? Divide both sides by length. So width is area divided by length. What's the area?
25x squared.
Okay, and the width?
We don't know that yet.
Oh, sorry, the length. Thank you. 5x. Good. Okay, so this is similar to what we just dealt with. So when we're dividing a monomial into a polynomial, divide each term by the monomial. So what would that equal? 5, yeah, 5 what? 5x minus 2. Very good. Minus 2. Okay, one more, and we're done. What is the volume of this tank?
Approximately 0 decibels.
What? What's the formula for volume of a tank? Length times width times height.
It isn't making any noise, so I'd assume that it's
Oh, okay.
0 decibels.
I don't get it. Okay, what's the length? Okay, 4m plus 2 times 2m times m. Now when we multiply, we can only multiply two things at a time, right? If I was multiplying 2 times 3 times 4, there's a few ways you can actually solve this. You could go, okay, well that's 6 times 4. Or you could go, okay, 2 times 12. Right, we multiply two things at a time. So which two can we multiply together first? You could bring in the 2m here, or what's easier? 2m times m. So what's 2m times m? 2m squared. Now what could we use? Yeah, what property? What law? Distributive law. Okay. So 4m times 2m squared. Okay, 4 times 2? 8. Is that m times m squared? M cubed plus 2 times 2? 4, and then m squared. There's our volume. Okay, so your homework works out that this lesson's on a short day, short lesson. So your homework's on the next page. Okay, on. No, we're talking about units. It's just the variables, yeah. Okay, so your homework, whenever we substitute in, you substitute in your number in brackets, okay? So, for example, in number 2, if I'm substituting in m equals -4, every time you see an m, that -4 should go in brackets, okay? So that's what it would look like, and then you have to solve from there. If you don't put it in brackets, you're going to make mistakes, okay? Because here, is this the same as this? Is -4 squared with brackets the same as -4 squared without? No. This one, what's -4 squared with brackets? Not equal. It squares a -2. So -4 times -4 plus 16. Here you're just squaring who? The 4. So this would be -16. So they're not the same thing. And that's why whenever you substitute a number, especially a negative, it has to be in brackets. Okay? So that's your homework, and then the answers are on the next page. And if there's some time, I'm going to start the next lesson because I'll let you do some work and then we'll see.